Hello everyone. In today's lecture, today's revision video, we will discuss about differentiation topic. These videos are important for revision purpose for J Mains, J Advanced, MSCT and other competitive exams. Differentiation. The first you have heard about is that ILAT rule or LIAT. E rule L stand for logarithmic function, I stand for inverse function, A stands for algebraic function, T stands for trigonometric function, and E stands for exponential function. Uh, Next is if when we do differentiation, it is represented by f dash x. So starting with the first basic is, if we differentiate x raised to the power n, we get x raised to the power n minus 1 into n. Second formula is this can be derived by the upper formula, but it is very important. So differentiation of root x is 1 by 2 root x. Other is a differentiation of 1 by x is 1 upon minus x square. Other important formula is that log of differentiation of log of x is 1 upon x. Then next other formula important is differentiation of e raised to the power x is e raised to the power x. And if there is e raised to the power ax, then differentiation of e raised to the power ax would be e raised to the power ax multiplied by differentiation of the power. Next is the next is a raised to the power x. Differentiation is a raised to the power x times log of a with base e. Now trigonometric functions differentiation, some important basic functions. First function is sine of x. I have written here sin, but sine of x, differentiation of sine of x is cos of x. Second is differentiation of cos of x is minus sine of x. Then is differentiation of tan x. Tan x differentiation of secant square x. Differentiation of cot of x is minus cosec x. Differentiation of secant x is secant x into tan x. And differentiation of cosec x is minus cosec x into cot x. You must notice one thing, that all the terms starting with c, cos x, cot x, cosec x end with negative sign. So this is the shortcut that which starts with c have negative answer in its differentiation. Mm, Now next, now there is a formula which is quite used in differentiation, that is multiplication of uh, s- two functions. Suppose first function is u and second function is v. So differentiation of second function into first function plus differentiation of first function into second function. um, Generally differentiation is also represented by that function upon dash, c u into v dash plus v into u dash. Now other important is that division formula, that what will be the differentiation of u upon v. So the differentiation here, in the upper case the order does not matter. Here the order does not matters. Here order does not matters, but here order matters. Differentiation of first term multiplied by second term minus differentiation of second term multiplied by first term divided by the square of the second term. It simply is that v into u dash minus v into v dash divided by v square. Now differentiation of some important substitutions. First substitution is that if you got 2x upon 2x divided by 1 plus x square, then it's then you have to substitute x is equal to tan theta. If you got the factors like or terms like 1 minus x square divided by 1 plus x square, then you have to put x is equal to tan theta. If you got the terms like 3x minus 4x cube or 1 minus 2x square, then put x is equal to sine theta. Uh, it, I will explain you the first one, why this substitution we are taking. For this, you need to know little trigonometric knowledge that if we put instead of x we put tan theta, it will become 2x tan theta divided by 1 plus tan square theta, which is 2 tan theta formula. Next is um, sorry, actually I was wrong here. It will become twice of sine theta. Actually said wrong. It will become if we put x is equal to tan theta, in the first case it will become as 2 sine theta, and if we put tan theta in the second case, it will become 2 cos theta. And for third case, that is the formula of 3 sine theta, the upper 3x minus 4x cube. Now next formula is that if 4x cube minus 3x or 2x square minus 1, then put x is equal to cos theta. Next is if root of 1 minus x square, then put x is equal to sine theta or x is equal to cos theta. See here, so you have know the identity that sine square theta plus cos square theta is equal to 1. So that is basically 1 minus sine square theta or 1 minus cos square theta if you put that in terms of x. Next is that root of 1 plus x square. So similar identity, put x tan theta or cot theta. Next is that if root of a plus x divided by a minus x is there, then put x is equal to a twice of cos theta. This property is very much important. One thing I forgot to tell is that um, differentiation of inverse function, differentiation of sine inverse x, when condition is important that x must be between 2 minus 1 to 1, its differentiation is 1 upon root of minus 1, 1 minus x square. Similar is for cos inverse x. The condition is that x must between 1 to minus 1, and its differentiation is minus 1 divided by root of 1 minus x square. The other is tan inverse of x, where here x belongs to r. Here condition is important that x belongs to r, and its differentiation is 1 divided by 1 plus x square. Other important is cot inverse x. Here also x belongs to r, and its differentiation is minus 1 divided by 1 plus x square. Other important is that secant inverse x. Here important condition is that x is greater than 1, and its differentiation is 1 upon x root x square minus 1. And the last inverse function is cosec inverse x, is x greater than 1, and its differentiation is minus 1 x root x square minus 1. Here you will see similarities between sine inverse and cos inverse. Range is also same of x, only difference in the sign. Tan inverse and cot inverse, range same, difference only in sign. Sec inverse and cosec inverse, range same, only difference in the sign. Now let's continue to our other part. Other part is that this how will you find differentiation of, if question comes x raised to the power x, how will you find differentiation? There is a standard method that y is equal to x raised to the power x, then take log on the both side, that x will come down, then do differentiation by product rule. That can be done, but x raised to the power x is most frequently asked question, so you can directly learn differentiation of it, that x raised to the power x differentiation is x raised to the power x multiplied by 1 plus log of x. Now this is not a compulsory, but it's a general form that if an I told you about x raised to the power x, but what if a function raised to the power g, where f is the function of x, g is the function of x, and where f and g both are different functions, then the formula is this formula is complicated. In this case, you just take log on the both side. This formula is for just reference, that y times g into f dash by f plus g times ln of f. Now the next important thing is in differentiation, LCD limits continuity differentiability. It is the next chapter of differentiation integration. After that, this chapter comes in some where it teaches before also. So some important points, that limit if x tends to 0, then limit of e raised to the power x is 1. If x tends to 0, then limit of e raised to the power x minus 1 divided by x is 1. uh, if limit x tends to 0, log of 1 plus x divided by x is 1. Then limit x tends to 0, then limit of a raised to the power x minus 1 divided by x is log of a. And log, all here I talk log with log base e, not log 10. Next is log, if x tends to infinity, then limit, this is limit not log, it is just written limit 1 plus x, 1 plus 1 upon x into x is e. Then if x tends to 0, then limit of 1 plus x raised to the power 1 upon x is e. This is very important limit. This limit, I am shading it with gray. This limit is very much important. It is used in many functions. Then if x tends to infinity, 1 plus a upon x raised to the power x, this limit is also important. It is e raised to the power a. Then other important limit is if x tends to 0, then sin x is equal to 0. If x tends to 0, then cos x is equal to 1. These trigonometric limits are very much important. It is very much used. Uh, these limits now I am telling are very much important. That if x tends to 0 and it is sin x upon x, then it is 1. Then other is if x tends to 0, then tan x upon x limit is 1. And if x tends to 0, limit of 1 minus cos x upon cos x is 0. Now some inverse limit is that limit if x tends to 0, then limit of sine inverse of x upon x is 1. This limit, and this limit is very much important. And this limit is also very much important, that limit of x tends to 0, tan inverse of x divided by x is 1. This limit is also very much important. Now the if a question comes that limit x tends to 0, x raised to the power n minus e raised to the power n divided by x minus a, then limit is simply n times a n minus 1. This limit is important. This limit is used in many questions, that if x tends to 0, limit of ln of, that is log of 1 plus x divided by x is equal to 1. And the last limit property, lip property of question, this property also is very much important, that if limit x tends to 0, a raised to the power x minus 1 divided by x is equal to ln of a. So that's all for my side, and hope you understood all things which I have tell you. This just a revision video. If you do not understand anything, comment down, and thank you for watching this. Have a nice day.